This is chapter 4, section 2, problem 22. Let's look at one like it. Use a computer or statistical calculator to calculate the correlation coefficient in parts A through C below. The table below shows the approximate distance between cities and the approximate cost of flights between those cities. Calculate the correlation coefficient between the cost and miles. So they have this here to give us the cost in miles. So we can open this up in StatCrunch. Interesting. So in part A, we can go from stat. And regression. Simple linear. X var is the cost. The Y variable is miles. And then we can compress. Now we have the option here to select the fitted line. So I'll go ahead and put it in here. See what happens. Then we can press the compute button. And we have here the information. The dependent variables, the miles, the dependent variables, the cost, and they give us the linear equation there. The size of the sample, the correlation coefficient, okay, and the coefficient of determination, R squared, okay. We have the estimate error, standard deviation there. So you can see the intercept and the equation, the intercept and the coast. The standard error between the samples there. Okay. Now if I click on this, what is that? Less than symbol there. Here, it gives me a plot, dot plot, a plot, scatter plot. And you have that regression line, the line of best fit. Okay. And that's what they're looking for there. So you can see what R is. I'll go back. R, correlation coefficient, is there. 3 decimal places. And part B shows the same information except the distance was converted to kilometers. Multiplying the number of miles by 1.609 and round to the nearest kilometer. What happens to the correlation coefficient? Let's find out. So see, right now the correlation coefficient is 0.908. So let's run it the same thing again. StatCrunch, stat, regression, simple linear. X var is cost, Y var is kilometers. You can press the compute button. So what happens to the correlation coefficient? R here, it's the same. It's the same. Notice that the correlation coefficient is found in A and B when numbers are multiplied by a positive constant. Here for the kilometers, it doesn't change the correlation coefficient. Supposing that the tax is added to each flight, $75 is added to each flight. The cost here, no matter how long it is, the table shows new data. What happens to a correlation coefficient then? So let's find out. So we can go to stat, regression, simple linear. In this case, we have cost in miles. And I press the compute button. Correlation coefficient stays the same. It's the same. So